Our team is composed of 3 biomedical engineering students at Wichita State University: myself, Mariah Mendoza, Tyler Loddick, and Blaze Miller. We share the goal of identifying a clinical need and developing a solution to the problem. We set off to Wesley Medical Center to find our need. Wesley Healthcare has provided healthcare to over thousands of families in Wichita and throughout Kansas and northern Oklahoma for the past 100 years. Their mission statement says, "Above all else, we are committed to the care and improvement of human life." With this mission statement in mind, as well as their vision to bring exceptional health to every human being, they have been able to treat more than 24,000 patients annually and deliver more than 6,000 babies each year, more than any hospital in a 13-state region. Our observations were based off ethnographic research strategies. These strategies include full immersion into clinical sites, gathering observation through watching and listening, and conducting a series of interviews. We primarily worked with Dr. Bauman, a physician in the Wesley Family Medical Clinic. While interviewing residents in the pediatric center, we came across a clinical need. The residents shared with us their concern for misplacement of nasogastric tubes in children. This interview, coupled with extensive research, brought us to our needs statement. A way to address the issue of verifying the placement of nasogastric tubes. This would lead to an increase in safety and accuracy during the initial placement and throughout the course of treatment. It would also eliminate the use of potentially harmful treatments such as radiation that could affect the patient later on in life.
In the U.S., there are roughly 1.2 million nasogastric tubes placed annually. However, the rate is unknown in children. All patients in need of nasogastric intubation require verification of the tube placement. While conducting research on the problem, it was found that the methods of verification used today are only 80 to 85% accurate. People that are neurologically impaired or ill are especially vulnerable to displacement as their gag reflex is not as strong. NG tubes have a price range of $2 to $80, excluding placement costs. This product accounts for 11% of the internal feeding device market, with companies such as Abbott Nutrition, Nestle, and Fresenius controlling 75% of the revenue share. Currently, abdominal radiograph is the gold standard used for placement verification in nasogastric tubes. However, other methods of verification exist, including ultrasound, capnography, and use of electromagnets.
After looking over existing solutions, our team has come up with 2 concepts to combat the issues and limitations that come with placement verification. The first design concept is an electromagnetic tracing device. The device will be located at the circumference of the tube ending. An external receiver, monitor, and software system would track and verify the electromagnetic position within a coordinate system in the body. The device would automatically turn off and on at set intervals or on demand to regularly check the location while reducing energy use and heat production. And finally, an alarm system would notify the attendant if the position has changed from the programmed location. The device is modeled similarly to that of the Cortex system. Improvements include the development of making the device used for continuous placement verification rather than just initial placement. Limitations currently restrict the use of electromagnetic tracers in tubes small enough for children. Our device would combat this issue with a cylindrical hollow design. In addition to the first concept, we had developed a device that could possibly work in tandem with it to increase accuracy. The second concept would be a pH reader at the end of the nasogastric tube. The pH in the stomach has a pH that is very distinguishable from the rest of the body. It will wirelessly transmit pH data from the tube to a separate monitor or device. It will have the ability to transmit live and instantaneous readings to ensure accurate and effective data. This would eliminate any electrical wires and cords that would be necessary from a conventional system that uses circuitry to obtain pH readings.
This product will specifically target the patients needing nasogastric intubation. This provides a sizable target market with the ability to affect over 1 million patients. Our product offers an advantage that other competitive products are not able to offer. Our product will offer the peace of mind to the patient, knowing that their nasogastric tube is properly placed and they do not have to worry about the negative consequences of misplacement. It will provide regular confirmation of placement rather than only initial verification to assure the efficacy of the product. It will have a variety of placement verification mechanisms in place to ensure maximum accuracy and a low margin of error. This concludes our video presentation over the verification and placement for nasogastric tubes. We plan to continue working to improve and modify our current solution. Thank you for listening.